Exponential decay. So let's look at this. So let's see the graph so then it can help us answer this fill in the blank. So an exponential decay graph looks something like this. We're always going left to right. So what we would say, the y value does when the x increases. So as x increases, right, we're going this way. What happens to y? Well, it decreases. So therefore, we're having, right, like this is going to be a negative exponential decay right here, right? Negative decay, that makes sense. So now let's look at the equation. So it's just like our last one, right? We have our starting amount. We have the amount at a given time, like time t, right? E is still going to be Euler's number. 2.718 with infinite amount of digits. K is going to be our constant. It's going to be negative this time. And T is for time. And then the next thing we need to talk about is half-life. Because we're decaying, so we're going to talk about half-life, which is the time it takes for half of the material to remain. So that makes sense. So half of it's going to remain, and that's the life. So it's just like the time. So let's look at an example. Example 1. A person drinks 40 milligrams of caffeine in the morning. The half-life of caffeine is about 5 hours. So that means for half of it to be gone, it's going to take 5 hours. Now we're going to use our equation to solve for things. First, let's solve for K for this. So we have 40 milligrams, and we know the half-life, which is about 5 hours. So we actually have a lot of information. So this will be our starting amount. And then we know then the kind of the time or the given amount at a certain time was going to be 20 because we're going to look at 40 and 20. So we have 20 here, 40 here, right? We're using our equation, E, and we're solving for K. So we do know the time, which is going to be 5 because we're going to put, for time, we're going to deal with hours here. And we have K that we're solving for. So in the next thing we're going to do, right, we're going to go 20, and then we're going to actually divide both sides by the 40. So we have really 1/2. Now, like before, in order to get rid of RE, we have to take the natural log on both sides. So let's do this. The natural log of 1/2, and then the natural log of e to the 5k. Remember, this becomes, right, it goes 5k times the natural log of e, right? This essentially just pops out to the front of the natural log. This just becomes 1. So now we have the natural log of 1/2, which is equal to 5k. In order to get just k by itself, we just go ahead and divide by 5 on both sides. So we're left with k, which is equal to the natural log of 1/2 over 5, or divided by 5. Actually, let's get our really fun calculator out. I really like our Desmos calculator, so let's go ahead and do this. So we're going to go to functions. Now we're going to take the natural log 1 divided by 2, which is equal to negative 0.693. Now we take negative 0.693, and now we're going to go ahead and divide it by the 5, and what do we get? We get negative 0.1386. So that's our K value. Notice it's negative, which is what we want it to be in this. So now let's do part B. We solved for K, so now we can use that. How much caffeine does the person have in their body after 12 hours? So what's important to remember is that the 40 milligrams is going to stay with us. So we still have the 40 milligrams as our starting amount. We have E. Now we have 12 as our time, not the 5 like in the first part. And we have our K value. And then we're just solving for A, when T is equal to 12. Right, it's like a function. So let's go ahead and solve. We'll get our calculators out. I'm gonna put this over. Actually, I really like this one. So let's go ahead and use this one. So we have 40. And then we're gonna go times function. Let's solve. Find e to the x, because we need to have something that goes up on the exponent. We're going to do brackets, and we're going to go our 12, then times our K value, so negative 0.1386. Whoops, this did not work. There we go. And then we just close the brackets and we can go ahead and say enter. And what do we get? We get 7.58. So this is equal to 7.58, right, when we multiply this all out. This is going to be in milligrams. Now let's do with part C. How long until there's only 10 milligrams of caffeine in the body? So part C, this means that we're going to have our ending amount going to be 10. Then we have 40 still. We still have E. And then we still have our K. Except now we're solving for time. Right? Like that's essentially what we're solving for. Because everything else we can fill in. So like before, we're going to go ahead and divide by 40 on both sides. Then, in order to get E, kind of get rid of E, so we get rid of the exponent, we'll take the natural log on both sides. So we'll take the natural log of 1/4, because 10 divided by 40 is 1/4. We'll take the natural log of E to the negative 0.1386 t, which essentially we get natural log of 1/4, which is then negative 0.1386 t times the natural log of E. This just becomes 1, which is great. Then we can go ahead and divide by on both sides this K value. Then we get T all by itself on the right hand side. So let's get our calculators out. So we'll go to the function, take the natural log, 1 divided by 4. And we'll close it. And then we're going to go ahead and divide by negative 0.1386. And what do we get? Well, we get 10.00. So that's essentially 10. So what's our time? That's going to be 10 hours until there's 10 milligrams that were remaining. Now, let's go ahead and look at another example in the next video.